Hello, so this is a revision video for IB Chemistry S1.2.2, Isotopes and Atomic Mass. This is a revision video, so only the essential information is covered. For more detailed explanations and full video lessons, please check the links in the description below and visit chemistrystudent.com. Isotopes are atoms of the same element that have different numbers of neutrons. Because they are the same element, they have the same number of protons. This means isotopes have the same atomic number, but have different mass numbers. For example, carbon contains naturally occurring isotopes including carbon-12, carbon-13, and carbon-14, meaning an atomic number of 6. However, atoms of carbon-12 have 6 neutrons, atoms of carbon-13 have 7 neutrons, and atoms of carbon-14 have 8 neutrons, giving mass numbers of 12, 13, and 14. The chemical properties of isotopes are identical because they have the same number of protons and electrons. However, their physical properties can be different, such as mass, density, and rates of diffusion, as well as radioactivity. The relative atomic mass, AR, of an element is the weighted average of the masses of its isotopes. This is needed because most elements exist as a mixture of isotopes, meaning if you take a sample of an element, it will contain atoms of different isotopes. So the average mass of an atom in that sample will actually be based on all the isotopes that are present. As a result, relative atomic mass is calculated from the mass of each isotope present and its percentage abundance, meaning how much of it there is. The relative atomic mass is calculated then as the sum of each mass of isotope times its percentage abundance divided by 100. For example, chlorine has two main isotopes, chlorine-35 and chlorine-37. The percentage abundance of the 35 isotope is 75%, and the percentage abundance for the 37 isotope is 25%, meaning 75% of chlorine atoms in a sample are chlorine-35 and 25% of chlorine atoms in a sample are chlorine-37. The relative atomic mass of chlorine then would be 75 times 35 plus 25 times 37 divided by 100, given a relative atomic mass of 35.5.